Good morning, Vishwanath.
Good morning, Amritanshu.
What are you reading?
This is a story about Gauss.
Gauss. Isn't that the unit of magnetic flux density or something?
Yes, that too, but he was a very famous mathematician. It is said that when he was 7 years old, his maths teacher wanted to keep the class quiet for a little while and decided to give them the following problem. Add up all the numbers from 1 to 100. And unfortunately for the teacher, Gauss came up with the answer in no time. He said it's 5050 in just a couple of seconds.
Wonder how he did that. Let me try. So let me look for a pattern. So we have 1, well, that's equal to 1, 1 plus 2, well, that's 3, 1 plus 2 plus 3, that's 6. See, I'm hoping that if I try out enough of these, I'll see a pattern and then I'll be able to guess what happens when I go all the way up to 100. So 1 plus 2 plus, so I'm getting the sequence 1, 3, 6, 10, 15. I can't seem to exactly spot the pattern over here.
Yeah, looking for patterns is of course a very good way of going about many of these problems. But what Gauss did was actually very clever. So let me show you what he did. He just wrote down the numbers from 1 to 100 two times, once in the forward direction and once in the reverse direction.
Let me try it with the numbers from 1 to 10. So I write them forwards and I write them backwards.
Yes.
10 plus 9 plus 8 plus 7 plus 6 plus 5 plus 4 plus 3. Okay.
Okay,
So
and
I've
now
got,
if you add all these up together, you get twice the answer that you're looking for.
okay.
So now what you do is you add them up along the columns.
Let's see. So you're saying I add 1 to 10, that's 11. Then I add 2 to 9, oh, that's also 11. And then 3 to 8, that's also 11. I guess these are all going to be 11. 11 plus 11 plus 11 plus 11 plus 11 plus 11 plus 11. So how many 11s have I got? Obviously 10.
Yes.
So 2 times the sum is 11 into 10. And so that means the sum is 11 into 10 divided by 2, which is 55. That's nice. I guess.
Can you do the same thing with 1 to 100, which is what Gauss did?
Okay, that's a lot to write. So let me just start writing and then I'll put, okay, 1 plus 2 plus 3 and then I'll just say dot 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 and this goes all the way up to 99 plus 100. Okay, and then I write it backwards. So that will be 100 plus 99 plus 98 plus, and then this would be 2 plus 1, and then I do the same thing. I add them up by columns, so I get 101 plus, okay, that's also 101. So they are all 101. And how many 101s do I have? I have, so 2 times the sum is 100 101. So it's 100 into 101. So the sum is half of that. So that's 100 into 101 divided by 2, which is 50 into 101, which is, well, as Gauss said, 5050. Amazing.
That's how we got it in just a couple of seconds.
What was the pattern in those numbers I was looking at earlier? 1, 3, so 1 plus 2 is 3, 1 plus 2 plus 3 is 6, 1 plus 2 plus 3 plus 4 is 10, 1 plus 2 plus 3 plus 4 plus 5 is 15. Wonder what this pattern is. I guess I could do that in general, right? Why just 100? Let me try to, okay, so I don't know how many numbers I have to add, but let's call that n, and so I have to add numbers from 1 plus 2 plus 3 all the way up to, well, n minus 1 and then n. And now let me write them backwards. So I get n plus n minus 1 plus n minus 2 and so on, and that will end with, I am writing them backwards, so I will get 2 plus 1. And now let me add up these columns. So that gives me n plus 1. This also gives me n plus 1. So I am getting n plus 1 each time. So 2 times Sn is n into n plus 1, which means that Sn is n into n plus 1 by 2. So these numbers are just the sequence whose nth term is given by n into n plus 1 by 2.
Yes, in fact, they are called the triangular numbers, and let me show you why they are called the triangular numbers. So we are trying to add the numbers 1 plus 2. So let's put 2 of these kinds here. Then 3, that's 3. So 1 plus 2 plus 3. So I put 6 coins now, and plus 4 and so on. So you can see the triangle forming up when you try to add these numbers.
Nice. So what about numbers with other shapes?
Yes, you could also try and make square numbers in a similar fashion.
Like 1, 4, 9, 16, 25?
Yes, indeed, that's what we call the squares. But in fact, these are also just the sums of the various odd numbers. For example, just like what Gauss did, we could look at 1, 1 plus 3, 1 plus 3 plus 5, 1
Let
plus
me
3
try.
plus 5 plus 7 and so on.
So 1, so that's 1, 1 plus 3, that's 4, 1 plus 3 plus 5, that's 4 plus 5, so that's 9, 1 plus 3 plus 5 plus 7, so that's 9 plus 7, that's 16, 1 plus 3 plus 5 plus 7 plus 9, so that's 16 plus 9, 25, 1, 4, 1, 4, 9, 16, 25, these are the squares of numbers, okay, the square numbers.
Right.
I see.
And do you think you can do the same sort of thing that Gauss did to actually add up these numbers?
Let me try. So, so you're saying I should write them forward and backward,
Yes,
and see what happens. So let's try. So let me write 1 plus 3 plus 5 plus 7 plus 9, and then I write them backwards. 9 plus 7 plus 5 plus 3 plus 1. Okay, and as before, I add up the columns. So here I get 10, nice, 10, oh great, 10, 10, 10. So 2 times the sum is, I guess there are 5 odd, I am adding the first 5 odd numbers, and so 2 times the sum of the first 5 odd numbers is 10 times 5, and so the sum is 25, the square of 5. I guess I could do this in general, right?
Yes,
just like I did it before. I would write, I would add up the first n odd numbers. So what does that mean? So I have 1 plus 3 plus 5, let me see, the nth odd number. So the 10th odd number is Okay, so the 10th odd number is 19. So the nth odd number should be 2n minus 1. And I write them in reverse order. So I'll have 2n minus 1. Before that, I would have had 2n minus 3. Before that, I had 2n minus 5 and so on. And then this will go all the way up to 1. And you said I should add up the columns again. So 2n minus 1 plus 1, that's 2n, then 2n minus 3 plus 3, that's 2n, this is also 2n. So I get how many 2n's? I get n 2n's, right. So 2 times the sum is n multiplied by 2n, which means that the sum, let us say call this Sn, so the sum of the first n odd numbers is just n squared. That even seems nicer than the sum of the first n numbers, right? I mean, the formula is so simple.
Right. And let's see if we can play with carom coins similar to what we did for the triangles.
Okay,
so
let's do it.
Let's do it. So now you're trying to add 1 plus 3 now, and then plus 5. So let's do it slowly. So let's try and do this first. 1 plus 3 plus 5, and we'll just play with it a little bit. So I'm just going to move my black coins here. So that's 1 plus 3. I've just rearranged them in a slightly different shape. Now here are 5 white coins, which we rearrange in this manner. Okay, and let's also throw in 7 black coins. So I have 1 plus 3 plus 5 plus 7. So here are 4 plus 3 more black coins, and let me arrange these like this.
A square again.
Okay, so you see what I did there.
So you have the odd numbers added up and they form a square.
So we just sort of bent them a little bit so that it formed squares. And so this sort of tells us right there that if you add 1 plus 3 plus 5 plus 7, for example, you can form a 4 cross 4 square, and therefore it must have 16 elements or 16 coins.
I see it so clearly now.
Yes, this is sort of what Gauss did too.